Okay, so for these, let's see what you remember. So for this first one over here, with a standard inch ruler, what's the first thing we need to know before we can figure out that whole implied range? So the first thing is degree of precision, right? How do we find the degree of precision on a ruler like this? It's been a few days, hasn't it? The degree of precision is the smallest division. So on this ruler, there's 1, 2, 3, 4, 5, 6, 7, 8. So 16 divisions within an inch. That means each division is 1/16 of an inch. That is our degree of precision. From that, then, we need to figure out what is our maximum built-in error, which is going to be what? It's always half of the degree of precision. So 1/16 times 1/2 is going to give us 1/32 of an inch. So the built-in error is plus or minus 1/32 of an inch. So that means the implied range, if the object is reported as being measured at 7 5/8 inches, it's 7 5/8 minus 1/32 up to 7 5/8 plus 1/32. So 7 5/8 minus 1/32 is 7 19/32 of an inch. 5/8 becomes 20/32. 7 5/8 plus 1/32 is 7 21/32 of an inch. Does that look familiar now? Good. So if we're given a metric measurement like this with a decimal, and we're not showing the ruler that was involved, how do we get the degree of precision? Well, the degree of precision in this case is just the place value of the last digit. What's the place value of that 9? The tenths, so 0.01 centimeters, or 0.1 centimeters, 1/10 of a centimeter is our degree of precision. So now the built-in error is half of that. So 0.1 divided by 2, or 0.1 times 1/2 is 0.05. So plus or minus 0.05 centimeters. So that means our implied range is 23.9 minus 0.05 up to 23.9 minus 0.05. Yeah, it should have been plus. Sorry. I said minus both times into... Yeah, it's early in the week. So 23.9 minus is 23.85 centimeters. To 23.9 plus is 23.95 centimeters. That's the range. That one look familiar as well? You want to do one more? You're not ready for a quiz yet? That's good, because we're not. So here's the ruler, and we have an object that is reported as 2.5 inches. Then we have another one that is 4.38 centimeters. Find the range, implied range for each of those quick. Okay, so for the first one here, what's the degree of precision? Degree of precision, the smallest division is 1/8 inch. So the built-in error, plus or minus 1/16. Very good. So the range from 2.5 would be from 2 7/16 inches up to 2 9/16 inches. How many of you had that? No? Did you see where it came from now, though? Okay. Yeah, the biggest thing is you got to count between. That's why I have to go from one whole inch to the next. You got to count 1, 2, 3, 4, 5, 6, 7, 8 divisions. So that's where the 1/8 comes from for the degree of precision. Then you divide that by 2 or multiply by 1/2 to get 1/16. So plus or minus the 16th for the error. Then to get the range, you take the measurement and you subtract the 16th. To get the lower end, then you take the measurement and add the 16th to get the upper end.
Yeah,
Okay. Okay, that happens. So now for the metric, the degree of precision is with the place value of the last digit. So this one is going to be 1/100 of an inch because this last digit is in the hundredths place. So 0.01 inches. The error will be plus or minus 0.005. That's not inches, by the way. That should be centimeters. Why am I saying inches? So 0.01 centimeters and 0.005 centimeters is our error. So that gives us an implied range. 4.38 minus the 0.005 is 4.375 centimeters. 2 plus the 0.005 is 4.385 centimeters. How many of you had that one right? Cool. Anybody not understand where it came from yet? Okay. So, our new stuff today, so I'll give you a second to get that down. We're going to be talking about some precision measuring devices. For those of you in dairy herd, this might not be as applicable, but it's still good to know. We're going to look at using a caliper. A caliper is this lovely little tool right here. The proper way to read a caliper is actually, oops, you gotta be careful, it's like this. So your main scale looks basically just like a ruler, and it's divided up. Now, most calipers are divided up in whole inches and then tenths on the main scale. Then this is a dial caliper, so you have the dial that shows you the hundredths and thousandths. So this will go down to 1/1000th of an inch. You'll notice there's this little roller right here that you can use to open and close it. You can just grab the jaw and move it, which works fine. The only thing is when you get really close to where you want to use this, because it has slippage in it, so that once you're tight, it'll slip so you don't mar the surface of what you're measuring. One of the dangers is actually closing it down, and since it measures to 1/1000th of an inch, if you close it too tight, it can actually indent or mar the surface of the object or the jaws of the caliper and throw your measurement off because you're sunk into the piece a little bit instead of just measuring the surface. Now, the first thing we need to do with any measuring device is make sure it is calibrated, zeroed out. For a caliper, one of the ways you do it is you close the jaws and you zero it out. So you can see it's on 0 on the dial when the jaws are closed. So that means this is calibrated at 0 inches. That does not mean that if we get out here to 3 inches, which is somewhere in there, does not mean we're calibrated on 3 inches. So we have to be careful. Calibrated at 0 inches, zeroed out like this, and that's what they call it, is zeroing it out. Means that it is calibrated for things close to 0 inches in size. The further we get away from that, the more likely it is to be out of calibration. Two things happen with these. One, it's metal, so it's temperature sensitive. Most measuring devices, most steel calipers like this, are calibrated between 68 and 72 degrees Fahrenheit. So if it's hotter or colder than that, the steel may have expanded or contracted enough to throw it slightly off. You guys ever hear of gauge blocks? If you ever really need a precise measurement on something that's bigger than an inch or so, like I said, zeroing it out, you should be good up to an inch or so. But if you're looking at 2 or 3 inches, they actually make precision gauge blocks you can use. And so you can put it in here and make sure, put in a 3-inch gauge block and make sure it reads exactly 3 inches. If this is not zeroed out, let's say you close the jaws and it looks like this. Right now it is closed tight, and you can see that that is not on 0. I don't know if you can see it in the camera or not there. there is this little screw here that loosens up the face of the dial, and you can see the dial actually rotates. So you close the jaws and you rotate it and you put it at 0 and you tighten that screw so the dial stays put. If you're using a 3-inch gauge block, you would make sure you said the number 3 here is lined up with the 3 inches and then still 0 out the dial. So that is where we start. So anyway, let's take a look at actually measuring some things with it. Let's look at some actual measurements. So here is the face of a caliper. And you can see here on the main scale, we do have full inches. This is 2 full inches is what that number means. It's just slightly bigger than the other numbers. It's 2 full inches. Then these marks are the tenths. We read this particular caliper, we read at the edge of the jaw. Now, if you're not sure where to read your caliper, you just close it down, and whatever lines up with the 0, that's where you read the main scale of the caliper. So here this is past the 5. So this is 2.5 inches so far. And then we go to the dial. This is on 15. That's thousandths of an inch. That's another 1/5 on the end. So 2.515 inches is what that's saying. This one, how many whole inches? 5. How many tenths? Past the 6, so 5.6. And then the dial? 21. So 5.621 inches. How about this one? 3.6 and then 66. So 3.666 inches. This one? 4. Now, is it to the 0.9 yet? Oops, here we go. How can we tell?
Because it's right behind the line of the...
Okay, yeah, here would be 0, and it's not quite back to 0 yet, which means it hasn't quite made it to the next division. So this isn't quite to the 9 yet. This is just 4.8, and then this says 87. So 4.887 inches. So then here, this is how many whole inches? 0. Point. Is it to the 3 yet? No, we're not quite to 0, so it's going to be 0.271 inches. This one, 4.4, and then 43 inches. Do this one in your notes quick. See what you come up with. So, how many whole inches? 1.1 tenth, and then 42 inches. Perfect. So now we're going to look at a little bit different style caliper here. This is still an inch caliper, but you can see the jaw is set up differently. If I close down the jaw, the edge of the jaw is going to be right here. That does not line up with the 0. So the part that would line up with the 0 here is going to be this part right here. So that is where we're going to read the main scale. So this is still 0 whole inches. It is 0.5 and then 63. So on this one, how many whole inches? 0 point. Are we to the 8 yet?
No.
Yeah, we just passed 0. So we have passed the 8. So 0.8. And then, what does it say up here? 14. So 0.814 inches. 0 whole inches, right? Then we're past the 0.8 here. So that's 0.8. To make sure that we're past that, we look here. We just passed 0, which means we just passed the 10th mark. So that means we just passed the 8. So it's 0.8. Then this is 14, so it's 14 on the end. So if we look at this one, we've passed the 1 whole inch. So that's 1 point, but we're not to the 1/10 yet. So that's 1.0. This piece right here. Yep. That little piece is where we read this one. See, now when we were doing this one, we read it at this edge. This is a little bit different style, so now we read it at this little notch. So it's 1 whole inch, 0/10, and then the dial is saying, Kyler, don't answer if I don't ask a question, okay? So 0.46 inches. So 1.046. So then this one, do we have any whole inches? We have 1 whole inch. Do you have any tenths? What is it? 2/10. Here's the edge. It's between the 2 and the 3. Then on the dial it says 61. Does that make more sense now? You still look confused. So you've got 1 whole inch. Then the tenths, 1, 2. It's not to the 3 yet, so that's the 2. Then the dial is the hundredths and the thousands, so 61. This one? Yeah, but when you're dealing with the tenths, it's between the 2 and the 3, so you just go to the smaller one as the 2. It's past the 2, but not past the 3. This dial is telling us how far past the 2 we are. So that's where we get the 61. So like here, the whole inches, that's the bigger number. We're past the 1. So it's 1 point. Now, to tell, we're right on the 6. So either we're just getting to it or we just passed it. So we look at the dial. We just passed 0, which means we just passed the next mark. So that means we just passed the 6. So it is 1.6. If the needle was over here, that means we're not to the 6 yet. So it'd be 1.5. Does that make sense? So it's 1.6, and then this is 9. So it's 09. So you always have to get 2 digits off the dial. So here, whole inches is 1. Now, to tell, we're right at the 9, so we got to look up here. We have not quite made it back to 0 yet, which means we're not quite to the 9 yet. So it's only 8, so 1.8. So that's a little tricky. Does that make sense? Yeah, we haven't quite made it to the 0, which means we didn't quite make it to the 9 yet. So then off the dial, we have 96, so 1.896 inches. So here, whole inches, 2.1/10, yep, and then 37. I'm going to try this one in your notes. Oops, that's the same one, isn't it? How about we try a different one in your notes, like this one. Do this one in your notes quick, see what you get. So we have what? 2 point, are we to the 5 yet?
Nope.
No, we're not quite back to 0. So 2.486 inches. Good. So this one is 2.836. This one, 3.437. This one, well, here's the 6 and the 7. We're not to the 7 yet, so it's 3.6 and 53, so 3.653. Now we're going to change styles just a little bit. This one here, we're only going to do a few of them because it's not that common anymore, but it's the 16th of an inch, or actually it's not 16th, the 64th of an inch caliper. So it goes to within a 64th of an inch. So you can see on the main scale here, we do have the whole inches, 1, 2, 3, and we do have, I believe this is 16ths marked out in between it, but we don't even have to read anything. All we need to get off the main scale is the whole inches. This is 1 whole inch. Then this dial actually goes through a complete inch. So 0 to 64 64ths. To read it, what we need to do is we need to find the nearest marking that is labeled. This is labeled as 1/8 of an inch. So that we can count up, though, we need to convert that into 64ths. So what do I do to change an 8 into a 64? It's times 8. So I take 1 times 8 to get 8. So 1/8 is 8 64ths. Just a little review of fractions, right? So this is 8 64ths. So this would be 9, 10, 11 64ths. So it is between the 10 and the 11 64ths. Which one is it closest to? The 10 64ths? It's really close to being right in the middle, isn't it? I'd probably say slightly closer to the 11 64ths. So that is 1 and 11 64ths of an inch. This one here is 0 whole inches. We're not to the 1 yet. So now off the dial here, 1/2, of course, is 32 64ths. So 33, 34, 35. It's between 34 and 35. Which one is it closest to? It's probably slightly closer to the 35. How about this one? Any whole inches?
1.
We're past the 1 whole inch. So now it looks like 5/16 we're going to go off of. How many 64ths is 5/16? So I have to do 16 times what makes 64? 4. So 5 times 4 is 20. So 20 64ths. So that's 20. So this is 21, 22. It's dead on 22 64ths. Now 22 64ths, however, I'm not going to leave as 22 64ths. Both 22 and 64 can be divided by 2 to give me 11 30-seconds. So 1 and 11 30-seconds inches. How's about this one? Well, 1 whole inch and it's on the 7/8. That's easy enough. How about this one?
2.
It's 2 inches and not quite to the 5/8. So let's count backwards from the 5/8. So 5/8 is going to be how many 64ths? 8 times 8 is 64, so 5 times 8 is
40.
So 40. That's 40 64, so this would be 39. So that's 2. Because this is marked out, and every one of these marks here is a 64th. See 1 64th?
Oh, I guess.
They can be. So that's what you got to look here and see what that says. These are usually only used in cabinet making. It's about the only time you ever see a 64th inch caliper. They're not real common. That's why we only did, a half a dozen or so of them here. Here is a metric caliper. Now this main scale is marked in centimeters. The problem is this is marked in 0.01 millimeters. So the way we read one of these is we actually, instead of reading this as 1 centimeter, we read it as 10 millimeters. This is read as 20 millimeters. And then what that means is, like this is 20, this is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So now here, are we past that 3 or the 30 millimeter mark? No, we've just passed 0, which means we had to have just passed it. So that is 30 point, that's 31. So 30.31 millimeters. No, because that's got to be read as 30, because it's centimeters. That would be 3 centimeters and 0.31 millimeters, and then you can't mix those in the metric system. Because these are in centimeters, you have to make that conversion and read that, instead of reading that as a 2, that has to be read as a 20. What's that? Okay, so this is 20, 21, 22, 23. It's not to the 24 yet because we're not back to 0. 23.96. millimeters. So then this one. Try that one in your notes quick. See what you come up with. So, again, we're reading it here. So this is past the 5. So that's 50, 51, 52.41 millimeters. Try this one. Okay, so how many? So this is 10, 15, 16, 17.77 millimeters. How many got that one right? Good deal. So this one, this is where it gets tricky. It's less than 1. Is it past, this is 9 here. Is it past 9? Yes, because it's past the 0. Right, so that's 9 point. Now, I just said less than 1. It's below the 1, so that means it's less than 10, right? Is that 1 is a 10? So, but it is past the 9 because we just passed 0. So that's 9.12. How about this one? 62.48 millimeters. How about this one? 6567.47 millimeters. These actually are kind of easier to read once you get used to this being a 50 and not a 5. So this is 80, 85, 86.81. Yeah, that's the only hard part is remembering that's not 8, that's 80. So this is 440, so 45, 46.50. Do we need the 0 on that? No. Actually, mathematically, yeah, we don't. It's 46.5 and 46.50 are numerically equivalent. But since this is a measurement, that 0 tells us that we did measure to the 100th of a millimeter. So technically, we should keep the 0 on there. This one is 22.37. Perfect. How about this one? Is it past? This is 25, 6, 7, 8. Is it past the 28? Yes, it's past 0, so it's past the 28.28. 28.28. And this one? 5, 25, 6, 7.60. And again, we should have the 0 on there. Any questions? Okay, well, I have a packet for you guys to use. I'll pass out the packet, and then I'll give you back your old tests. So in this packet, we should have covered pretty much every type of one that's in the packet, so you should be able to do the whole packet.